So in this video, we're going to be talking about y equals to mx plus b. So first of all, we're going to be talking about what this even means, and then we're going to be doing some questions in which we're going to be constructing equations in the form y equals to mx plus b using some given information that we have. Okay. So first of all, this is known as the slope-intercept form. And why is it known as that? It's because just by looking at this equation, we can immediately tell the slope and the y-intercept. So that is why this is known as a slope-intercept form. So an important thing to note here is that we can only write linear equations in this form. And so you might ask, what are linear equations? Well, linear equations basically are those equations that when you graph them, we get a straight line. So if we graph an equation, we get a straight line, that's a linear equation. If we graph an equation, we don't get a straight line, we get a curve or something else, then that's not a linear equation, right? That's a non-linear equation. Okay. So that's let's just so y equals to mx plus b, right? So in this, m is just the slope and b is the y-intercept. Okay, so what is slope? So slope is basically, it has a sign and it's a number, right? It's a number along with the sign. So that slope tells us two things. It tells us the direction of the line. So the direction of the line is told by the sign of the slope. So if it's positive, then the line is going in the positive direction. If it's negative, it's going in the negative direction, right? So the sign is all about the direction, and the number attached with the slope, that's all about the steepness. So slope tells us two things. It tells us the direction of the line, and it also tells us how steep the line is, right? Now the main question is, how do we even calculate slope? So the basic thing that we have to know is that in order for us to calculate slope, we need 2 points in the graph, right? So imagine this is our first point, and we have a second point somewhere up here on this graph, right? Let's take this to be our example. So this is a 1 point, this is a second point. So when I compare those 2 points, I'm gonna have I'm gonna have to travel some distance in the horizontal direction to arrive at that point, right? And I'm gonna also have to travel some distance in the vertical direction in order for me to arrive at that point here, right? Now, the distance that I travel in the horizontal direction, that is known as run, right? And if the distance is towards the right, the run is positive. If the distance is towards the left, the run is negative, right? Okay, and similarly, so here's my run, and here's going to be my rise, right? So if the rise is upwards, it's going to be positive. If the rise is downwards, it's going to be negative, right? So rise over run, that's how we calculate the slope. Okay. So that's one way, right? The other way is to actually take the coordinates of these 2 points and use this formula, y2 minus y1 over x2 minus x1. And so this basically is just a change in the y values of these 2 points and over the change in the x values of these 2 points, right? And on the next board, we'll do a question in which we're going to be using this and this, both of these methods, to find the slope. Okay, so the next important component of this formula, of this equation, is the y-intercept. So the y-intercept is just basically where the line intersects the y-axis, right? So let's take this to be our example. So this line intersects the y-axis at a point, right? So in this case, that point is 2, right? So in this, if you were to write an equation of this line, the b is going to be 2. Now, why don't we care about this 0 here? Well, we don't care about this 0 here is because of the way in which we defined our y-intercept to be, right? So the important thing here is that the x-coordinate is always 0 at the y-intercept, right? So we're always going to have 0 here at the y-intercept. So that's why we don't care about this 0, and the y-intercept is just this y value of this point here, of the point where the line cuts the y-axis, right? Okay. Now let's move on to some questions here. Okay, so our first question here is to write an equation for a line with slope equals to 2 and y-intercept is equals to -4. And this is very simple, right? So we saw that y equals to mx plus b, m is the slope and b is the y-intercept. So
So we've been given both of these things here, right? So we know the slope and we also know the y-intercept. So our job is just to plug in the numbers inside this equation and then we're done, right? So here we take this equation and we plug in the numbers. So y equals to slope. Slope in this case is 2. So in the place of, we replace the m with 2 and 2x and minus 4. And why minus 4? Because in the place of b, we replace this b with the y-intercept. In this case, the y-intercept is negative 4. So we have y equals to 2x minus 4, and that's our equation of this line, which has a slope of 2 and which has a y-intercept of negative 4. Okay, let's move on to our next question here. So the next question is to write an equation of the following line. So we have this line drawn for us here, and we want to find an equation in the form of y equals to mx plus b for this line. So to write an equation in the form y equals to mx plus b, we need to know two things. We need to know the slope and we need to know the y-intercept. And we know that y-intercept is just a point where the line cuts the y-axis, right? So in this case, we can see clearly from this graph that the y-intercept is just 5, right? We can see that here. And that's what I've written down here. So y-intercept is just 5, and I took that directly from the graph, right? You can see that from there. Okay. The next thing that we have to find is the slope. And according to, so we have two ways in which we can find the slope, right? So slope could either be rise over run, or we could use this fancy looking formula here as well. Okay. So to use the rise over run, what I need to do is that I need to zoom into this graph, and that's what I've drawn here. So I kind of zoomed into this graph and I saw how much is my rise when I move from this pink point all the way to this orange point. How much do I have to move in the upward direction, right? So rise is the vertical direction, right? So I have to move 2 units upwards. So it's going to be upwards is positive, right? So rise is just 2 and run divided by run. So run in this case is going to be 4. And why are both of these things positive? It's positive because if we move upwards, it's positive, right? In this case, we move upwards. If we move towards the right, it's positive. In this case, we do move towards the right, right? So that's why it's both of these are positive. And when you simplify this, 2 1s are 2, 2 2s are 4, we get 1 by 2. So slope here is 1 by 2. Okay, let's use this other method. And for this other method, what we need to do is that we need to choose any 2 points on the graph, right? And in this case, I chose my 2 points to be my purple point and my orange point. And it doesn't matter which 2 points we choose, we're always going to get the same slope. And that's the beauty of linear equations, right? Their slope remains constant along the entire line, right? So that's something that, so no matter which 2 points I choose along this line, I'm going to get the same slope. So the first thing that I have to do is that I have to call one of these points point 1 and one of these points point 2. It doesn't matter which point I call point 1, point 2. I just have to make the decision in the beginning, right? That's what's important. So in this case, I made a decision to call my orange point point 2 and my purple point to be my point 1. Okay. Now, what is y2? What does this even mean? y2 minus y1. So y2 just means take the y coordinate of my second point. So this 2 here means the second point. So in this case, I chose my orange point to be my second point, right? So I take the y coordinate of this point here. In this case, what is the y coordinate of this point? Well, we can see it's 9, and we can also see from here it's 9, right? So the y coordinate is 9 of this point. So we write 9 here and then subtract it with the y coordinate of my first point. So y1 is just the y coordinate of my first point, and that in this case is going to be 7, right? So 9 minus 7 divided by x2 minus x1. Now what is x2? x2 is just the x coordinate of my second point, and that in this case is going to be 8, right? So that's 8, and then x1 is just the x coordinate of my first point, and that in this case is going to be 4. So 8 minus 4, and so 9 minus 7 divided by 8 minus 4, that gives me 2 over 4, and that's 1 by 2, right? So I used 2 methods to calculate the slope, and I got the same answer, and that is what I expected, right? So no matter which method I use, I'm going to get the same answer. Okay, so my slope is 1 by 2, and my y-intercept is 5. And now I can go ahead and write my equation in this form. So I have the equation is y equals to, in the place of m, I write the slope, which in this case is 1 by 2, x plus 5. And how do I get my 5 here? Well, 5 is just a y-intercept. and that I took directly from my graph. And that's everything.